Welcome to another video. In this video we are going to solve problem number 287, that is find the duplicate number. In this problem they will give an array list of nums containing n plus 1 integers where each integer is in the range of 1 to n. So if there are n plus 1 integers, then index will vary from 0 to n. So they are saying that each value varies from only 1 to n, but there are n plus 1 integers. So that means there is a duplicate value in the given array. So we have to find the duplicate value. So along with that problem statement, they have mentioned some additional constraints where we cannot modify the values of the array and we should only use constant extra space. So one easy way to solve this problem without any of these constraint is we can keep a hash data structure hash set, and we can keep on inserting elements into that set. So whenever we find a duplicate, we can return that element. That is one way to solve it. So if we don't want to use that much of extra space, we can modify the array elements. So we can store negative value of this array elements. For that main point here is when we have values from 1 to n, this can be directly mapped to index 0 to n minus 1. So that way we will be able to map this thing to unique position, and then we can store a negative value at those positions, and then we can find out the duplicate value. That is one way of doing it if we are able to modify the nums array. So in this problem we are going to use some different technique to use a constant extra space and modifying without array elements. That is Floyd's algorithm, where it can be used for detecting a loop in the linked list. So if we can understand that, and then we can try to come up with mathematical proof where we will be sure that how to find the starting of the loop. First we need to understand how we can model this problem into a linked list problem. So I am going to explain that with an example. In the problem statement, they have mentioned that nums have values from, there are n plus 1 elements in the given nums array. So index varies from 0 to n. If there are n plus 1 elements in an array, index can vary from 0 to n. And in the problem statement, they have also mentioned that each value in the nums array will vary from 1 to n. Nums of I will have a value from 1 to n. And then what this indicates? This indicates that there is a duplicate, because each value varies from 1 to n, and they are saying that there are n plus 1 elements, so there should be a duplicate present. So with this understanding, we can try to model this problem as a linked list. So let us consider this first example where the given numbers are 1, 3, 4, 2 and 2. So what we should do is I will write the index also. For this we have to, since we know that each value nums of I varies from 1 to n, this can be considered as a pointer to next element. So value stored at a nums of I is pointer to next element. So keeping this in mind, we can model this problem as a linked list problem. Each nums of I vary from 1 to n, which is well within the index range. So our index range will be from 0 to n. Since value vary from 1 to n, then there is no problem of going out of boundary. So with keeping these things in mind, let us model this problem as a linked list problem. Let us start drawing the linked list. At index 0, we have no incoming links, and 0 is pointing to 1, because value present at index 0 is 1. At index 1 we have a value of 3, then it means 1 is pointing to 3. At index 2 we have a value of 4, that means 2 will be pointing to 4. We still don't have any links to 2, we can write it as a separate link. So 2 is pointing to 4 because value present at index 2 is 4. So at index 3 we have a value of 2, then this means 3 is pointing to 2. And at index 4 we have a value of 2, this means 4 is pointing to 2. So by this we have transformed our list into a linked list problem, where if you observe the starting of the linked list loop, it points to the repeated value because it has multiple links coming into it. So now we have transformed this problem into a linked list problem. We just have to find the starting of the loop in a linked list. For that we can follow Floyd's algorithm, which is a similar technique which is being used for detecting a loop and detecting starting of the loop. Let us go through some mathematical proof how we are arriving at this technique. So for detecting loop in a linked list, especially we use two-pointer technique where slow and fast. I am writing some random linked list with a loop to understand some terminology that we are going to use it for mathematical proof. So this is, let's say this is the linked list and we have to find starting of the loop in this list. So initially slow and fast both will start from the head, and then slow will move by one position, that will be slow equal to slow dot next, and fast will move by two positions, fast equals to fast dot next. And let us say they will meet inside the loop, because once they enter the loop they will keep on iterating over that loop and they will meet at some point, because speed of fast is more than the speed of slow. So if two persons are running inside a circle, and if they don't have a matching speed, then they will meet at some point. We are considering some arbitrary node as the meeting point. Let's say they meet at 6. So then let us write some variables to indicate the distance. P is the distance from starting of the list to start of the cycle. Let C be the cycle length, and we can consider this distance as x actually. So C is the cycle length, that is number of nodes which are present in the cycle, and that will be C minus x, because C is the total number of nodes and x is the distance from meeting point to start of the loop. C is the length of the loop. Now what we can do is we can compute the distance traveled by the slow pointer. So before meeting the fast pointer, how much distance our slow pointer has traveled? It has obviously traveled p, and it may have gone through some cycles. Let us write it as n times c. It has gone through p and it may have gone through some cycles n times c, and it has traveled additional distance of c minus x. And what is the distance traveled by the fast pointer? Let us write the distance traveled by the fast pointer as well. Distance traveled by the fast pointer, so it has obviously traveled p distance, and it may, if slow pointer goes through n cycles, then it has gone through 2n cycles, and it may have gone through additional k cycles and then additional c minus x distance. So this is the distance traveled by the fast pointer. Since we are moving fast at a 2 times speed, then we have to take care of these cycles as well. So we know that distance traveled by the fast pointer is 2 times the distance traveled by the slow pointer. By using this information, we can come with a mathematical proof for the starting of the linked list loop. So distance traveled by the fast pointer is 2n cycles due to k, and then k additional cycles, and then c minus x distance. This is 2 times the distance traveled by the slow pointer, n times cycles, and c minus x additional distance. If we start simplifying these equations, then we can compute further. So 2 times nc 2 times c and minus 2x. And let's bring everything to the left side and start simplifying this equation further. So 2p minus p becomes p and 2 and c will get cancelled, and we have a I'm getting a little bit confused here. Anyway, we are going to simplify this equation further. KCC, because if we bring that x to the left side, it becomes minus x plus x. Let us simplify it again. P minus 2p, we are bringing everything to the left side, and then kc plus c minus x, and if we bring 2c to the left side, it becomes minus 2c, and if we bring minus 2x to the left side, it becomes plus 2x equal to 0. Now we can simplify minus p and c times k plus 1 and minus, okay, plus minus x plus 2x becomes plus x, and we neglected a 2c. So let us simplify it further. Minus p plus c minus 2c becomes minus c, and plus kc and minus x, that will be plus x. 2x minus x becomes x equal to 0. And now if we can simplify this thing, if we move the p to the right side, then it becomes p equals to x plus c times k minus 1. So this is what we need to understand this equation further in terms of what is happening in terms of slow and fast pointer. So after simplifying this, we got this equation p equals x plus c times k minus 1. What this means is, let's say if there is a linked list, and I'm writing this again so that this distance, what we mean by p, x and c, becomes very clear. So we are considering this meeting point as 6, and this distance becomes c minus x, where c represents the number of nodes in the cycle and p is the distance from beginning to start of the cycle. So what this means is, if we move a slow pointer, if slow pointer moves from p distance, then if fast starts at a meeting point, then it makes k minus 1 cycles plus the x distance. So if we make the move slow by p distance, then fast will make k minus 1 rounds and x distance if we start at meeting point. So here we are not moving at a double the speed, but we will move at the same speed. So I hope you understood this technique, and with keeping these things in mind, we can start writing the solution for this problem. Let's write the solution for this problem using the discussed technique, where initially we have to treat it as a linked list. So nums of I represents the next pointer, and if we take 2 times, if we consider, this becomes next dot next. So initially we have 2 pointers, both will point to 0, slow and fast, because this is the starting of the linked list, because all the values vary from 1 to n. So we are sure that there is no such value which is 0 inside this nums array. So there will be no links coming to slow, no links, and will be coming to 0. So this ensures that 0 is not part of any loop. So we will start both at 0, and then in this problem we are sure that we are going to meet at some point. So we are going to write it inside a infinite loop which is going to break once they match with each other. Then we have to move the slow pointer by one position. For the next pointer, we just have to consider the value present at slow. So we have to move fast by 2 positions. So if we do fast equals nums of fast, then this means we have only moved one time. So we have to move again. So we have, for moving again, we have to consider that pointer as well. So we have moved slow and fast, and at some time, if there is, we know that in this problem there is a loop because of the duplicated value, this slow and fast will become equal. So at this position we are going to what we are going to do, so they have met at some point, we are going to break here. So this infinite loop will break out here. Now we have fast pointer at meeting position and slow is also at meeting position. So we have to bring slow to the head of the list. So slow will once again become 0, and once again we will start this infinite loop because we are sure that they are going to meet each other. For finding the start of the loop, we just have to start moving these pointers by one position at a time. So our next pointer will be nums of slow, and for fast our next pointer will be nums of fast. So if they meet at some point, then we know that that is the starting of the loop which represents the duplicate value. So we are going to return slow or fast, it doesn't matter. Let us submit this solution and check whether it passes the initial test cases. Yes, as you can see here, this solution is passing the initial test cases. Before submitting the solution, let us discuss about time and space complexity. For time complexity, we are going through the list to find a loop, and then we are going to go again to find the start of the linked list, so which is going to scale linearly with the size of the linked list. So our time complexity is O of n. What is the space complexity? For space complexity, we are not using much extra space which is going to scale with the size of the input. So we have constant space complexity. Let us submit the solution and check whether it passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithms, you can consider checking out other videos from my channel. Thanks for watching this video.